Uh, Good morning, everybody. Welcome to Oracle Service Bus course. Today, agenda is we are going to discuss about the key architecture of Oracle Service Bus, and we'll be discussing about the OSB in a nutshell and the messaging pattern of OSB. So, before starting with OSB, I'll just give you the background. OSB is a product which Oracle has acquired from another company called BA Technology. Previously, OSB was called as ALSB, that is Aqualogic Service Bus. After acquisition, Oracle has renamed it to Oracle Service Bus. Oracle Service Bus, like we can do the development in two ways. Oracle has provided an IDE, that is Eclipse, which helps in doing the development for the OSB services. Oracle has also provided a console, Oracle Service Bus console, where we can do the development as well. But for doing the development in console, like if we need to make small changes directly on the console, we can do it using the console. Otherwise, it is not preferred to do the entire development in OSB console, because if a particular project is there and if multiple users are working on the same project, so it's very difficult to make changes on that particular project when multiple users are working on the same project. Maybe whatever you are making the changes, it will get discarded and it won't get active, and the session won't get activated. It might go into some conflict stage. So it's better to use IDE, that is Eclipse, which Oracle has provided for the development. Small changes, like if you want to make some changes in the URL, those kind of small changes, that can be done in the console. And also another reason for not doing the development in the console is, since we'll be doing the changes on the server and multiple user will be using the server, and it will be slow. The development will be slow if you are going to do on the server. That is another reason, but it's a matter of choice. Either you can do in console or you can do on the IDE straight away. So when Oracle had acquired this product from BA, the parallel processing was not built in OSB product. So Oracle has acquired another company for doing the parallel processing. That parallel processing is called the split join in OSB. So we have this split join embedded in IDE. It's another product only, which is embedded in Eclipse as well as in the console. So let's start with the architecture. We are going to discuss about the logical architecture. We have the inbound layer, the midway layer is the Oracle Service Bus, and the outbound layer there is an outbound layer. In the inbound layer, we have the inbound transport and inbound binding. The middle layer is the proxy layer, that is the message processing layer, and the outbound layer is again the outbound binding and the outbound transport. What does inbound transport do? Inbound transport is basically a communication layer between the client and the Oracle Service Bus. The inbound binding layer it basically packs and unpacks the messages, and it hands off the message to the message processing layer. Whatever the message is coming to the Oracle Service Bus, it comes in the SOAP message format, and the protocol, the incoming protocol is the HTTP protocol. It's always the HTTP protocol that is used, that is for the incoming message in generally the SOAP over HTTP protocol for the message soap over is used in the OSB service. And in the OSB layer, we whatever message soap message we are getting, we can do the enrichment to that message. We can convert the soap message to any other format, and after changing the format, we can send it back to the business service via outbound transport layer. The outbound transport layer is the communication layer between Oracle Service Bus and the business service. So outbound binding layer can convert the SOAP message format to any other format, and outbound transport will convert from HTTP protocol to any other format like JMS protocol or file protocol, FTP protocol, etc. The proxy service is the message processing layer, whereas the business service is a dumb service. It doesn't do any message processing. So now this is the logical architecture of Oracle Service Bus. If you want to know about Oracle Service Bus, about the message processing layer, about the business service, then we'll start with the proxy service. Proxy services are a fundamental concept in the architecture of Oracle Service Bus. They are definition of intermediary web service that the service bus implements locally. It basically allows a configuration of proxy service by defining its interface in terms of WSDL and the type of transport it uses. Proxy service has got the message processing layer. We can base our proxy based on WSDL or any other message format like XML format or any XML message. It can be based on any format. Proxy means like it's an inbound layer. Always the sending system invokes the message proxy layer for sending the message. It has got its own message processing layer where the message processing is done. If you see this particular diagram, we can explain OSB in a nutshell. We have the service management in OSB where we do the transaction monitoring. SLA alerts are there. Like suppose if a particular transaction is taking a lot of time, suppose that particular response needs to be sent to the client in some 40 second or 45 second if it has exceeded, and we can raise an alert and it can go to the client via email or through JMS queue. Then we have the reporting action. Whatever we can report at each stage level what is happening in the service. We can report at each stage level about the progress of the transaction. Then we have the JMX, Java messaging extension. It tells you about the activity of JMS queue or topic, whether it is active or not active. Then we have a message brokering layer. It has the content routing, transformation, stateless orchestration. Since OSB has no database, we call it as a stateless feature. Whereas in SOA, it has got its own database, so it's a stateful. OSB is basically used for service orchestration, and BPL Oracle SOA is used for process orchestration. So what do you mean by content routing? It's basically the message driven routing. Depending upon the message content, it will route to various business service and it will do the transaction processing as per the routing. Then we have a transformation layer where we can transform the message format from one format to another format. We can also do the protocol transformation as well. Suppose we have received a message in SOAP over HTTP format and we want to send it in some other format, some other protocol. It can be achieved using transport protocol transformation. since we have talked about OSB has no database, it is stateless. Only for the reporting it uses its own database. Otherwise it is based on file system and it doesn't use the database at all. We can't see the transaction, since just like we have in Oracle, so we have the enterprise manager console where we can see the uh, instance details and all. Here in OSB we don't have that feature. We can't drill down into the instance and see the flow of the service. It is only after testing a service we can see the flow, but it is not saved anywhere. Then we have this config framework layer. We have a change management center. Change management center, it's kind of admin role. Suppose for each session, whatever activity has been done, suppose if you want to import a project into OSB, a session will be activated and you can see a session and created. If you see the view all session, if you want to undo any changes, you can undo the changes using the config framework. If you want to make undo to undo, that also you can do. Then we have a validation where we can validate the message, incoming message, whether it is a valid message or not as per the XST. If it is not valid, we can raise an error and we can send it back to the client stating that the incoming message whatever has been sent is an invalid one. Then we have an import and export utility. Using an import utility, we can import the jar file into the OSB project. We can build a jar file in Eclipse and we can import it in the server using the import utility. And suppose if we want to export a jar file, we have the provision of exporting it from the console. Then we have a UDDI concept over here in OSB. UDDI is basically for registering a service in a particular directory where the services can be reused. It will hold all the metadata information about the service. Then we have the service bus security, authentication and authorization, identity, policy, message security. In the service, we have the provision of creating the user for a particular. We have a provision of creating a user for the OSB. We have the service callout feature where we can authenticate and authorize the user for a particular service. We can attach that service callout to a service so that it will be authorized and authenticated. Then we have OSB supports different messaging protocols like HTTP, HTTPS, SOAP, JMS, EJB, RMI, MQ, SMTP, FTP, File, Tuxedo, etc. So we have so this is what OSB in a nutshell. If you want to know more about it, we have the explanation. We have the explanation in this particular slide. If you want to know anything about it, please go through it and let me know if you have any question on this. We'll move it to the next slide. OSB key context. It's basically for message context. The content of a proxy service is a set of XML variables that are shared across the request flow and the response flow. In OSB, we have a concept of context variable. We have a number of context variables like $header, $body, $attachment, $fault. Normally, whatever the incoming payload comes, it is there in $body. These wrapper variable contains SOAP header elements, SOAP body elements, and multi-purpose internet mail extension attachments respectively. The incoming payload is populated in dollar body by OSB only. Once the incoming payload comes, then in the message processing layer, we can do the message enrichment, or we can convert the message structure from one format to another. That is the job of OSB developer, and we can send that format to the business service. It will go to some other system. That is also a job of OSB development. Only when the incoming payload comes to the dollar body, that is populated via OSB, not OSB developer. Similarly, if we are expecting any response from the to the message processing layer, that also the also an incoming message to the message processing layer, that is also done via OSB, not via OSB developer. The context can be read and modified by xquery expression and updated by transformation and in place update actions. Since we were talking about the data processing layer in proxy service, we have a tab called as message processing, where actually the message processing is done for a message. We have an incoming payload. The implementation of proxy service is specified by the message flow definition. The message flow defines the flow of request and response message to the proxy service. The following 4 elements are used to construct a message flow: a pipeline pair, a branch node, a route node, and a start node. What is a pipeline pair? Pipeline pair is one for the request and one for the response. The pipeline consists of sequence of stages that specify actions to perform during request or response processing. Normally, it comes in a pair, one for the request and one for the response, and each for request and a response we can have stages, multiple stages we can have, and each stage will have some activity. What activity is getting performed on the incoming message, what callouts needs to be made to call the external business service. Here we can do the message enrichment, transformation, everything, validation, error handling, those kind of things. We can raise an error handling at this stage. And we have a branch node. Branch node, what it does, it will branch out based on some incoming message filter. Suppose it has to check some condition. Branch node is to branch based on value in the designated part of the message or message context, or to branch based on operation input. So we have a different kind of branch: operational branch, conditional branch. We can use those branch in the message processing layer. Then we have a route node. It is used to define the message destination. The default route node is an echo node that reflects a request as a response. If there is no message processing layer, then the route node is the echo node. Whatever incoming message is coming, the same response will be going. It is called as echo or pass through. So this is the message flow definition what we were talking about. Then we have a different OSB messaging patterns, like synchronous request reply, asynchronous request reply, subscribe push, publish subscribe, broadcast or fan out. Request reply is in the same thread. Suppose we in the same thread will receive a request, and in the same thread will be sending the response. In asynchronous, will receive a request and acknowledgement will be sent in the same thread, but the response will be sent at a later point of time in a different thread. Then we have a subscribe push. It's a one-way interaction. We can send a request and we don't expect any response. Similarly, we have a broadcast or publish. It's also a one-way interaction where we are broadcasting a message to multiple destination and we don't expect any response or acknowledgement. Another feature we have in OSB is for the parallel processing, what we call is split join. What it does is like we'll get a request, and we can process each request, and we can call the business service for that particular request in parallel or in a sequential way. Once the processing is done, we can accumulate the response, and we can sort the response based on the incoming request order, and we can send the accumulated proper order response to the client. This is the split join feature. So this was all about the OSB concept architecture, and for OSB component we'll be discussing on the next session. Thank you very much.